Hello again. My name is Javi Molino, and if you're just joining us, I am giving you little snippets of what to expect should you decide to attend a John M. Campbell G4 gas conditioning and processing section. If you've seen us before, then you're going to have to write in and see why I look different today than I did the last times. Today we are going to talk about pumps. Up to this point, we've talked about phase envelopes, we've talked about hydrate formation temperature, we've talked about system energy changes, we've talked about separators and heat exchangers, and today we will continue the discussion about pumps. Pumps are everywhere in our facility. They're so important that we typically spare them in the facility. During this session in a G4 class, you will be able to describe the principles of centrifugal and positive displacement pumps, explain the very important concept of head, and understand why the head rise is independent of the fluid being pumped. You'll be able to calculate the pump power requirements. You'll explain how to use pump curves, and you'll be able to understand why a pump is going to operate at the intersection of the pump curve and the system curve. You'll recognize why suction-specific speed is important. That's a concept that many facility engineers ignore or don't quite understand, and as a result, in their facilities, when a pump appears to be cavitating, they have lots of trouble trying to rectify or get to the root cause of the issue. You'll apply affinity laws for centrifugal pumps, which also apply to centrifugal compressors. And finally, in this section, you'll be able to describe centrifugal pump control methods. Today, what we will do is focus on the concept of net positive suction head available. One of the key points in understanding pumps is that the net positive suction head available must be greater than the net positive suction head required. The net positive suction head required comes from the vendor. The net positive suction head available comes from you. What we have on this sketch shows the determination of the net positive suction head available. This would be in your textbooks on page 131, and it's equation 14.6. You need to come to the course to get the textbook. Okay, what we show is a separator, and we have the suction pressure of the vessel, which is indicated by P sub S. We have a height of the liquid above the center point of the pump, which is noted by H sub S, and we have the vapor pressure of the liquid at going into the suction of the pump. The net positive suction head available is determined by this equation shown on the slide. It's some kind of constant. This is not an area, but it's a constant, times the pressure, the absolute pressure of the suction vessel, P sub S, minus the vapor pressure of the fluid, minus the frictional pressure drop, divided by the relative density of the liquid. To that, we add some various factors. HS is the only positive term in this equation, which is the height of the liquid above the center point of the pump. We subtract a safety margin, and if you're dealing with a positive displacement pump, we also subtract an acceleration head factor. If you have a bubble point liquid, you'll be able to fairly quickly determine what your net positive suction head available is. And again, to reiterate, it is critical that your available head be greater than the required head. When you attend a G4 session, you will find that we run lots of exercises, both in groups, individual, and things that we like to call thought exercises. This is an example of a thought exercise. Remember problem 8.9? That was the hydrocarbon dew point control unit that we talked about when that you evaluated in section 8, which was the energy changes. If you take the condensate from that hydrocarbon dew point control unit and assume that it flows into an existing constant speed electric motor driven pump, that's the assumption over here. That particular pump runs, but it's not consistent. The discharge flow rate and the temperature varies quite a bit. It requires a lot of maintenance, and it's been placed on the plant's bad actors list. You've been asked to investigate. What do you do? If you attend a G4 class, this is one of the things that we will discuss about what you do and how you can use the tools that have been presented to you in this chapter in order to put together a plan of action. Thank you for your time. Until next time, when we will talk about centrifugal compressors. Thank you.